Hello pre-calculus, I've got a new video for you. 4.8. So the last section we talked about, if you're given logarithms inside of an equation, what are we supposed to do to actually solve for x? We talked about the properties of the logs and how to basically consolidate one log on the left and one log on the right, and then do an exponential to undo the logarithmic operation. Now, what am I supposed to do if I can't find a relatively simple common base between two exponential functions, or an exponential function with a constant? Well, logarithms have properties in which the exponents can come down and become coefficients. And it works that way with every single log base. It doesn't have to be log base 10, doesn't have to be log base 7, doesn't have to be log base 2, doesn't have to be, pick your base. What we can do is we can apply the logarithm of any base to both sides, and that will bring us one step closer to solving the equation. So here's what I mean. If I take log base, and we'll just pick the one that's on the calculator so it's easy for us to work with these numbers. Log base 10, so I don't even put the 10 down there, of 2. Yeah, that's going to be the same thing as log base 10 of 7 to the 4x power if those two statements equaled each other to begin with. The log, no matter what base, is going to equal. So now, by doing this step, this little 4x takes on the property that I can now bring that and act as a coefficient to log of 7, right? So now I've got 4x times log base 10 of 7. Yeah, that equals the log base 10 of 2. Furthermore, since all of these parts are being multiplied by x, 4 times x times log base 7, I can divide by 4 log 7 on both sides to get x by itself. 4 divided by 4 is 1. Log 7 divided by log 7 is 1. So your answer is x is equal to approximately whatever decimal this comes out to be. So you will certainly need your calculator for this lesson. Hopefully you guys are equipped for that. So log, I'm just hitting the log button on there. All right. It implies it's a log base 7 of 2 divided by, now I want to put in parentheses for log 7, all right, because I'm dividing by both 4 and log 7, okay? So make sure you use the order of operations properly on that calculator, and you get 0.089. And if you want to check yourself on that, you can plug 0.089 into the x of the original. So, what is 7 to the 4 times 0.089? If this answer is correct, it should be pretty darn close to 2. All right? So here, take a look. Yeah, the rounding error is what created the 1.99 instead of it being exactly 2. So there's our answer. Nice. Okay, so we can do that with every single example. Oh no, I've got an exponential function. Log both sides. Log it. Log it. By applying the log to both sides, you create that situation. Let's create some space here. So you got 3 minus 2x now. That whole quantity is being multiplied by log of 4. Sorry, having a hard time handling all these markers. And then on the right side, I'm going to do the exact same thing. The red x plus 1 now becomes the coefficient of sorts, right? Coefficients are actually constant numbers times log of 3. Now there's a couple things you can do at this point. Most students, what they'll do is say, you know, I don't like dealing with these logs. The quicker I get them out of the equation, the better. So what you can do is you can come up with a like a decimal approximation for each one. Because here's what we got to do. We got to break open the parentheses. We got to take log of 4 times 3 and log of 4 times negative 2x. Okay? So 3 times the log of 4 gives me 1.806. And I'll be okay with you guys rounding on this assignment. Just round everything to the nearest thousandth, 3 decimal spots after the decimal. And then take negative 2 times the log of base 10 of 4. And you get minus 1.204x. Do the same thing on the other side. Log base 3 is now the coefficient of x. What is log base 10 of 3? And then that has an x. And since it's plus 1 times that, it's going to be plus 0.477 for that one too. So make sure you're keeping track of the fact that, hey, on this equation, I didn't do any decimals until the very end because everything was being multiplied by x. On this equation, I had to get rid of parentheses in order to get x by itself because I got to bring this x and this x together. And, if we did that with, we couldn't make this move right away because they were different from the get-go. So I'm gonna add this to the right-hand side. Subtract this from the left hand. Do some quick math. (1.681x) equals 1.329. Divide both sides by 1.681. And you should get approximately 0.791. So this is the basics of what's happening. Why don't you guys try the first couple steps on number 3 on your own? And I'll write it a little bit larger here so you guys can see it better. Pause the video, try it on your own. All right, let's see what you got. Log the left, log the right. That gets rid of the 2x squared plus 1 as an exponent, converts it to coefficient 2x squared plus 1 times log of 4. Now, I'm noticing there's no x's on the right-hand side. So if you want a quick shortcut here, by dividing by log of 4, it gets rid of it on the right or on the left. And then what you can do at this point is you can say, this is going to be some number, but I can compare it to 2x squared plus 1. So what do we got to do to get the x squared by itself? Well, I subtract 1 from both sides, right? And then I can take this whole thing and divide by 2. And that equals x squared. You can square root both sides. So that's a way you can skip some steps if you want to. Not sure you guys want to. Maybe you just turn the log base 10 of 15 over log base 10 of 4 and just find the decimal. Okay, this is not my calculator. square root of log 15 divided by log 4 minus 1, that's all inside the square root, and divided by 2. Oh my goodness. Yeah, it seems like this is, I probably should have broken this up into some smaller steps. That's my bad. Minus 1, divide by 2. Before square rooting, you should get 0.4767. I'm just going to take that to the half power because that's the same as square rooting it. And that gives me 0.690. Now, because of the square root, you have to honor the plus or minus. And here's the thing. Exponential functions can have negatives in their exponents. Okay? So it's not like we're going to have a bunch of extraneous solutions like we had with the logs. Yeah, it's gonna be pretty straightforward with these solutions. All right, I just realized that I have a Zoom meeting planned for my 6th-hour class really soon. What I'm gonna do is stop the video here, but then finish the notes numbers 4, 5, and 6 on a different one. It just might be a little time lag, so be patient. I'll come back to you with numbers 4, 5, and 6 on the notes. Maybe try them on your own just to see if you can get rolling with the homework without, the extra stuff. Bye. See ya.